In this video, we will use the StatCrunch normal calculator to work problems from section 6.2 in our book. And I've picked problem number 5 from the ebook to work on. And it says, assume that foot lengths of women are normally distributed with a mean of 9.6 inches and a standard deviation of 0.5 inches, based on data from the U.S. Army Anthropometry Survey. Find the probability a randomly selected woman has a foot length less than 10 inches. Okay, so what we're going to do, if you remember in this section we talked about standardization, but we're going to go use the StatCrunch tool because it will do that standardization for us. We'll put in the mean and the standard deviation, and then we'll put in what we want to know, and the calculator will do the work for us. So remember how we got to the StatCrunch tool. On our course homepage on My Stat Lab, click on StatCrunch website, and then from the website open StatCrunch, and you'll have a blank page, and you want to go ahead and go to Stat Calculator Normal. And I'm going to go ahead and make this a little bit smaller so I can put the two screens side by side. And let's bring this over here, and let's take a look here. So we know now this time in section 6.1 we used a mean of 0 and a standard deviation of 1 because we were working with the standard normal. This time we have an application, so we've got a mean and we've got a standard deviation for a particular distribution, in this case the foot lengths of women. So I've put in the mean and I've put in the standard deviation. We want to find the probability that a randomly selected woman has a foot length less than 10 inches. So I'm going to go down here to my inequality. It's less than or equal to, I'm going to put in 10 inches, and it's going to do the graph for me. And I notice 10 is greater than the mean of 9.6, and so my probability here is greater than half of the area. It's 0.7881. And then I want to find the probability that a woman has a foot length between 8 inches and 11 inches. So again, I'm going to go ahead and use my between tool, and I'm going to go here and go between 8 inches and 11 inches. I'm going to put in 11, and I'm going to do compute, and this is almost the whole distribution, and it's 0.9968. So I've captured almost all the women I would expect to have a foot size between 8 and 11 based on this normal distribution with a mean of 9.6 and a standard deviation of 0.5. And then finally they want me to find a percentile. And if you remember on this one, this is the z-score that corresponds to a particular area. And in this case, it's the percentile, the 95th percentile. And so I'm going to go ahead and I'm going to take out, I'm going to go back to the standard, and I'm going to take out the particular value here, and I'm going to put in 0.95 here. So I'm telling it the area probability, and it's going to calculate the z-score for me. So a foot length of 10.42 would be the foot length in inches that 95% of women would have a foot length less than that particular number, 10.42. Also want to point out here, you can also get, remember from the empirical rule, the tick marks on the graph, which is always kind of nice to look at. If we go back and look at that prior problem where we were going between 8 and 11, if you notice, 3 standard deviations below the mean is 8.1, so 8 would be beyond that, and I'm sorry, go back over here to the tick marks. Yeah, there we go. And then 3 standard deviations above would be 11.1. So between 8 and 11 is just about the whole distribution, which is what we found when we did that and found that answer for part B in the problem.